Hi, my name is Rabees Rafiq, and I'll be walking through the patent application that I've developed today. I'm going to walk through some of the trade offs as well as how the application works. But before I get into that, I want to give a very brief overview of what the application is intended to do, who the target audience is, and essentially what the value of the application is. So, the application is meant for inventors, entrepreneurs, engineers, scientists, or really anyone who is working within the patent space to identify new emerging technology, identify trends in terms of patent filing, and potentially in the near future, hopefully, even be able to identify instances of patent right infringement or so on and so forth. So, the application is structured in a couple different layers. The base layers are these external API routes. These are essentially functions that I've created, which invoke some type of external API either to Google Gemini or the main patent API. So this patent routes.py file contains the base APIs, which are used to invoke calls to the US Patent Office. And what you'll see here is there are some global variables which are used to essentially control limits, control retries, so on and so forth. These are the headers that are passed into that request call. These list of fields is what's returned to the end user. This can be modified. That's why I made it a parameter. And then this is really the main function which creates the JSON payload to then pass into the US Patent Office. So as you can see here, some logic there to construct it in that very specific format that's required by the API. And this is the key kind of pagination field which I use to then invoke multiple calls, because one of the intrinsic limitations of the API is you can only return 100 records. So as you can imagine, for very wide searches, this just invoking it once isn't too useful. These two methods are then wrappers which actually call and invoke the API. So one is a make search request function. This essentially is the main function which calls the patent search API and returns the patent records themselves. And then the second function and method is to actually get the patent documents and download them. So the second external route is this Gemini wrapper. And the reason that I did the Gemini wrapper is the data returned by the US Patent Office is somewhat sparse. There's are only a couple metadata and attributes that are returned, and they don't really give you a sense of what the actual invention or technology does. So I created this wrapper. It essentially invokes a call to Google Gemini, passes in a PDF document, and asks it to summarize it, identify limitations, identify competitors and market opportunities. And you can see it's using the Gemini 2.0 Flash Lite model for low latency, and also has this prompt which allows you to do all of the aforementioned things. The other portion of the application is the database itself. So as you can see, this is a database that I've created. It's storing data in as a pandas data frame. Some very kind of common methods such as getting data, adding data, returning all of the data, deleting data, and then clearing the data. I chose to use or construct this database as opposed to using something like SQLite or SQL Alchemy, just because I knew that the records or the volume of records was going to be pretty small, as well as it wasn't going to be anything that I was going to store long term. I think, over time, maybe could be something to consider is replacing this with something that is persisted kind of throughout as opposed to only within runtime. And then the next portion of the application is actually this setup shell. So this actually creates a Python virtual environment, and then installs everything that's required from the requirements.txt file, starts the Uvicorn, the Fast API server using Uvicorn, and then I'm using Streamlit for the front end. The reason that I use Streamlit for the front end is because this allowed me to use a lot of native Python packages and didn't require me to develop something in JavaScript or HTML. So I was able to use Python for everything, and it's a pretty nice front end with a lot of built-in features that I can take advantage of. The next portions that I'd like to walk through are the main.py. This is where a lot of the logic occurs in terms of propagating information or user inputs from the front end all the way to the back end, adding the records to the database. You can see here, this is essentially constructing the query which is required to then pass in to the JSON payload parameter. This is where the JSON payload is constructed, and then this is where the response is returned. As I mentioned, there are only 100 records that can be returned through the intrinsic patent API. So I've created this process which essentially paginates and offsets those records so users can download much more than 100 records at a time. Right now I've set this API limit to 10, but obviously this can be changed in a production environment. But this essentially invokes the patent API and returns records up to 1100 records. If this API call limit is changed, it can return even more. But it essentially takes those records that are returned in JSON format and then persists and stores those within the database that I've showed. These next methods are to return all of the database records for the front end. To download the patent, as I mentioned, many patent PDF files are returned. This finds the specific file for the patent spec itself. This processes the patent data, which is stored within the database, and reformats it to a format suitable for a line chart. This actually is a fast API route which returns the data for the line chart. And then very similarly, this processes the data and formats it for something suitable for a heat map. This is the fast API route which actually returns the data for the heat map, and then this is a clear database. The app.py contains essentially all of the modules and methods that the user interacts with on the front end. So I use Streamlit because, as I mentioned, can use a lot of native Python functionality and can essentially code all of this in Python. And this has a lot of the methods which run the query, take information from the user. A lot of the visuals such as the line chart and heat map are also developed here. And then this is where I store the patent data, allow the user to select it, download it, and summarize it via Gemini. So I'll actually go ahead and pivot to showing the application itself. So the way that a user would come in is they just come into wherever the app repo is, type in /setup.sh. This will go ahead and start running the environment, and this is the front end of the application. So as you can see, there are many fields that the user can interact with to run a query. Let's say a user is interested in identifying all patents filed by NVIDIA within these dates. They can come in here, type in NVIDIA in the application or applicant name, and then run query. Oops, sometimes that query fails the first time, but if they just click run query again, you'll see that now all of these records have been stored, and now they have the ability to see different trends within the patent submittals. They can see a heat map of where the patents are being submitted. It looks like here Texas, California, and Washington State. And then this actually shows them the tabular data of the backend where they can potentially select a patent. But obviously this doesn't give you a whole lot of information on what the patent does itself. This is where the next feature comes in. They can actually select any one of these records. Once they select these records in the table, they can then see a very quick summary of that record, and then they can actually click this button, confirm selection, and summarize patent spec. This will actually download the patent specification document, and you'll see a message is returned to the user. And after the patent specification document is downloaded, it will then take that document, upload it to Gemini, and actually summarize it via the prompt that I've shown. So as you can see, the download was successful. Please wait while the document is being summarized. I'm just going to pivot really quickly. Oh, looks like the response is returned. So you can see a summary, what the patent does, some of the limitations of the patent, the competing and emerging technologies, and then the potential market opportunity. And just to give you a sense of the utility of this feature, this document that was summarized was 87 pages, and you can see all documents are going to be stored in this directory right here. There's a lot of figures, a lot of text, so this makes it very easy for users to quickly identify potentially new emerging technologies. And then users can either clear the database and start with a new query. Let's say they want to look at Apple now. They can go ahead and rerun that query, and it'll essentially run that for Apple. As you can see, a little bit of a different output for Apple, but about 1,100 or so records are returned, and then they can do the same thing. They can select any one of these records, confirm it, and summarize it. So that's a quick walkthrough of my app. I hope you guys enjoy it. Please let me know if you run into any issues. I've put in the README some watch outs. Sometimes there's a process running on port 8000, which causes conflicts with the app, so you do have to kill that process. But yeah, hope you guys enjoy the app. Thanks so much.